Hello everyone, my name is Ruku Raju. I'm a geology faculty in KP classes. So today in this video we'll be discussing memory-based questions and solution of GATE 23 paper. So in geology GATE 23 paper, number of multiple selection questions and numerical question numbers were comparatively higher than the last year paper. So let's start with one of the numerical questions that I've asked in the GATE geology paper. So this is the first question that we are going to discuss. Formation water resistivity is 25. Resistivity of formation is given as 50. Saturation is given as 100%. Cementation factor is 2. Tortuosity factor is given as 1. And they have asked us to calculate the porosity of the formation. So this question should be like we have to answer it using the Archie's formula. So according to the Archie's first law, we know that the formation factor F is equal to porosity raised to minus M, where M is the cementation factor and phi defines the porosity. And F is the formation factor. And Archie's also given his observation that the resistivity of the rock, if we notate it with letter RO, is the resistivity of the rock, and RW is the resistivity of water. Then he have found the relationship between resistivity of the rock, which is 100% saturated. That's there, 100% saturated rock of having a resistivity RO, and the aqueous fluid have a resistivity of RW. Then the both of them are directly proportional to each other. That is, RO is directly proportional to RW, and he come up with equation RO is equal to formation factor, which is defines the effect of pressure of the rock matrix F into RW. So here, if I rewrite the equation by using this Archie's first law terminology, RO is equal to RW into 5 raised to minus M. So we have all the values of provided over here. RW is given, the RO value is given, M value is also given. You can easily calculate the formation. Sorry, we can easily calculate the resistivity. So resistivity raised to minus M is equal to RO divided by RW, and RO divided by RW will be equal to, like, these values are provided. RO is 50 and RW is 25. So RO by RW is equal to rho raised to 5 raised to minus 1. If I take it as 5 raised to minus M, then this will be 25 divided by 50. And we know that the formation factor is, so the M is the cementation factor. M is cementation factor, that is 2. So we know 5 raised to 2 is equal to 1 by 2. And if value of 5 will be 1 by root over 2. And this will be equal to 0.707. And in the question, they have asked to calculate it in percentage. So hence, the answer will be 70.7%. So this is the first question that we have discussed, formation water resistivity. All the terminologies are given: formation water resistivity, resistivity of formation, and they have asked to calculate the porosity. By following the Archie's law, we can easily calculate the value. Let's go to the second question. In Albate orthoplate system, one feldspar is formed in which, so the options were hypersolver situation, subsolvers, and third option was not in both. Fourth option was in both cases. So we know that in hypersolvers feldspar system, because a melt crystallizes completely to a single alkali feldspar above the solvers, so followed by the solid state solution. Whereas in subsolvers feldspar system, the solvus is truncated. So that causes no single range of mid-range of feldspar formation. Hence, the answer is hypersolvus condition. In hypersolvus feldspar system only, melt crystallizes completely to a single feldspar crystal or single feldspar condition, alkali feldspar above the solvus. So the answer is hypersolvus. Next question is about the order of wavelength of the electromagnetic radiation. So it was a very simple question, very direct question. So we know when it comes to the order of electromagnetic radiation, the smallest one is the gamma rays that has radiation of less than 10 raised to minus 12 nanometer wavelength. Then comes the X-ray that has a wavelength of 1 nanometer to 1 picometer wavelength. Then comes the picometer to nanometer wavelength. Then comes the ultraviolet radiation, which has a wavelength of 400 nanometer to 1 nanometer wavelength. Then comes the visible range, which has 750 nanometer wavelength to 400 nanometer wavelength range. Then comes infrared wave, which has a wavelength of 25 micrometer to 2.5 micrometers. Then comes the microwave, which has a wavelength of 1 millimeter to 25 micrometer. Then comes the radio waves, whose wavelength will be greater than 1 millimeter. Okay, so this is the very simple question. Is so if you know this order, you can simply get the order. I don't know the options, so I'm not writing the options over here. Simply the least wavelength will be of gamma, then comes X-ray, UV, visible, infrared, microwave, and radio waves. Next question was about contact metamorphism, and the question was about contact metamorphism causes whether a decrease in volume by surface area ratio, or whether there will be an increase in volume by surface area ratio. This was the question. So we know that in contact metamorphism, the grain size will be, when contact metamorphism happens, the grain size will be increasing to the protolith. Grain size increases, and when grain size increases, obviously surface area will be decreasing. When surface area decreases, like with a decrease in the surface area, there will be a decrease in the energy. With decrease in the energy, stability will be increasing. Right. This is the situation that happens when a contact metamorphism happens. So with increase in the temperature, grain size increases, surface area decreases, which causes a decrease in the energy condition, and thereby stability of the system increases. So though here in this condition, actually surface area by volume ratio is increases with increase in the grain size, or with this particular ratio over here. Sorry, this surface area is decreasing, and hence the surface area by volume ratio decreases. Surface area by volume ratio decreases with increase in the grain size, or with decrease in the surface area when with contact metamorphism. But in option, there is no value of surface area by volume decrease. Hence, we can go for this option, which defines there is an increase in the volume by surface area. So volume by surface area should increase with contact metamorphism, where the grain size increases and the surface area decreases. So let's go with the option number 2. Let's see the next question. So next question is a very simple question defining the lee side of the wave crest. That this is actually a question, we can say it's from geomorphology or from the sedimentology section. So the lee side of the wave crest is a wave crest ripple dips in 15 degree in the direction of north 10 degree west. What was the paleocurrent direction? we know that whenever it comes to the ripple mark, the store side and lee side, the direction of current will be in this particular way, where in whichever direction the lee side is dipping, that direction defines the direction of current. So here the options that I remember is these were the options. So in this option, when whichever direction the lee side is dipping, lee dipping in 15 degree in direction of 10 degree, no, west. So if this is the direction where the lee is dipping, this will be the down current direction, or this should be the paleo current direction. So the answer should be north 10 degree west. So this was a very easy question, not nothing to like think, like just the if you know about the wave ripple, like, and its morphology and how the current directions are shown, the question was a kind of easy question. Next question is they have shown a picture where in a bedding surface, these feature are called. So the picture was having there were set of cross laminations were there, and there is a surface, and this in this the surface there is truncation of different set of cross lamination was shown. So this was the picture. So actually this surface is called as reactivation surface. So options were faucet, angular unconformity, reactivation surface, etc. So when they asked to this one, these are cross laminations. So in between the cross beds, a minor erosional surface form is called as reactivation surface. So these are cross beds. Within a set of cross beds, erosional surface present is called as reactivation surface, which form during the tidal current because of the tidal current movement. A set of cross beds can be eroded, like the store side or the top part of the lee side can be eroded, and next set of cross bedding can be deposited on top of that erosional surface. So that is what is called as a reactivation surface. So the image, this surface is actually reactivation surface present in the formed in the cross bedding because of tidal movement. So let's see the next question. In the next question, it was all about the very easy, like they have given the number of symmetry element in the group 4 by m 3 2 by m group was given. We just have to find out the number of symmetry elements. So we know 4 by m 3 2 by m is hexoctahedral, and in hexoctahedral there are three fourfold axis symmetry of four threefold axis symmetry, six twofold axis symmetry are there, and there are nine mirror planes are there perpendicular to every axis of symmetry. So altogether there are nine mirror symmetries are there, and there is centrosymmetry also present. So altogether there is 23 number of symmetry elements present in the hexoctahedral. Options were 23, 21, 20, 26 were the options. The right answer is 23. So this was also a direct question from crystallography. Then the next question is minimum radius ratio. Minimum radius ratio value for coordination number of 3. This was the question. So we know there is a simple we can table radius ratio and coordination number. So if coordination number is 2, the radius ratio will be less than 0.155. The coordination number is 3, then the radius ratio will be at a range of 0.155 to 0.225. And if coordination number is 4, then the range of radius ratio will be, minimum value will be 0.225 and maximum value will be 0.414. If the coordination number is 6, then the minimum radius ratio will be 0.414 and maximum value will be 0.732. If it is coordination number is 8, then the minimum value will be 0.732 to maximum is 1. So from this value itself, we know like the minimum radius ratio for coordination number 3 will be 0.155. So if you remember this table, you can easily get the answer of this section also. This was also kind of a direct question. Next section is about, excuse me, they asked, I don't have the exact values, but the question was to define the bifurcation ratio. Like they have given the, to calculate the average bifurcation ratio, and they've provided the number of first order, second order, third order, and fourth order streams were provided. So fourth order, third order, all the streams numbers were given, order numbers were given, and we just have to calculate the average bifurcation ratio. So we know the average bifurcation ratio equation is NU by NU plus 1. NU is the order. So bifurcation ratio between first order and second order, we have to calculate. In the same way, you have to calculate bifurcation ratio between second order and third order, and same way third order to fourth order bifurcation ratio. Get an average of all these values, will get the answer. So average of all these values will be the answer of average bifurcation ratio. Okay, so this was also an easy question from geomorphology section. Then there was a question from uh, the structural geology. They have given a stereo net where the fault axis was going through the center. Okay, so this is the fault axis and this is the axial plane. Actually, the question was an MSQ question, multiple selection questions, and there were options, 4 options: recumbent fold, horizontal fold, upright fold, and vertical fold. So we know that in a stereo net, this is actually a very easy question, but the kind of tricky also. So this is, if you know about the Fluty's classification of fold, it is very easy. So we know what is a recumbent fold. Recumbent fold means when the fold axis is horizontal and the axial plane is axial plane is horizontal, we call it as a recumbent fold. Axial plane is horizontal and the fold axis is also horizontal, we call it as a recumbent fold. Horizontal fold terminology is for any fold that has a fold axis 0 or horizontal fold axis. Upright fold means fold axis is horizontal or 0, axial plane is at 90. Vertical fold means fold axis is also 90, vertical axial fold is also, axial surface is also 90. So this is a fold that has axial plane 90 and fold axis is also 90 situation. Now, in the question, see this in the stereo net, axial plane is passing through the center. The line is passing through the center. That means axial plane is dipping at 90. Fold axis is, the point is notated at the center. That means fold axis also dips, the plunge value is also 90. So these two values will is for vertical fold. So vertical fold is the fold that has hinge line plunges at 90 and axial plane dips at 90. So this stereo net question was defining, the answer was an easy question. It was about the vertical fold. Okay, now let's see the next question. Next question is about another set of structural geology question. So here they've given a picture. I'm not drawing it in a, I'm not a good, yeah, I somewhat managed to draw. Now, so here, yes, so here you can see that they've given an arrow in this direction. So the options were culmination, depression, horizontal bed, etc. These were the options. So this is actually in structural geology when it comes to the doubly plunging fold section. We know that there is a culmination. There are two different types of doubly plunging folds: culmination and depression fold. When it comes to culmination, means hinge line plunges away from the high point. That is called as a culmination. When the hinge line is plunging away from the um, highest point, we call it as a culmination. When the hinge line is plunging towards the lowest point, we call it as a depression. So over here they have notated that the hinge line is plunging towards the center, right, towards the lowest point. So this should be a depression. If they would have given the plunging directions, then we could say it is whether it is a synclinal depression or an anticlinal depression. That's not given. So this is actually a depression. So depression means the hinge line is plunging towards the low point. If the hinge line was plunging away from the high point, we call it as culmination. So from the picture, it is easy to define that it is a depression. Now there was another question from geochemistry. There was a question to calculate the half-life and decay constant. Related question was there. So we know the relationship between half-life and decay constant. Half-life is equal to 0.693 divided by lambda. So if you have used this equation to calculate the half-life and decay constant values, then the answer would be correct. Now there was another question from ore geology to define the order of reflectance of minerals. So from the memory, like the minerals were sphalerite, galena, pyrite, magnetite, and pyrrhotite. These were the options according to the memory, according to my memory and my students' memory. So this is actually, we know that reflectance of a transparent mineral is very less. For a transparent mineral, reflectance percentage will be of approximately equal to 5% or less than 5%. For precious metals like gold or silver, the reflectance will be much higher. 94-95% will be the reflectance. For oxides like magnetite, hematite, oxides, the reflectance is less. 10% to 25% will be the reflectance value. For sulfides, in the other hand, sulfides has much higher reflectance. It has a reflectance from 25% to 50% reflectance. So over here, we know that galena, pyrite, sphalerite, these are all sulfides. So magnetite will have the least uh, reflectance. So the reflectance value of galena is almost something related to 43-44%. Pyrite reflectance is much higher, 52%. Magnetite reflectance is very low. It is about 21%. Pyrrhotite is also has a reflectance value of 40 something 41, 42 kind of reflectance. Sphalerite is having less than this. So the value of reflectance, the order should be, highest value should be of pyrite, then it should be galena, and then the last value should be magnetite. So I don't know the options. So depending upon the options, you can choose by with respect to these three terms like pyrite, galena, and magnetite value. Whichever, pyrite and galena should be the first two having the highest reflectance. First one should be pyrite, then galena. Last one should be magnetite. So depending upon this, you have to depending upon the options, we can choose the correct answer. Okay. Now, the next question is about to calculate the order of maximum radioactive elements in granite. Order of maximum radioactive elements in granite between uranium, thorium, and potassium. So we know that 40 potassium, the radioactive potassium, which is one of the major element in potassium is one of the major element in granite. So potassium is present in feldspar, like the entire granite is made up of feldspar, right? Most of the percentage is feldspar and quartz. So potassium is one of the major element in the feldspar mineral. Hence, when you compare with potassium, thorium, and uranium, potassium content is much higher in the granite. So though potassium, 40K potassium is mainly present in feldspar, and biotite and hornblende of in granite usually consist of 40 K. Whereas when it comes to thorium, thorium is usually present in the biotite and hornblende minerals, and also uranium also present in biotite and hornblende minerals in granite. Then there are some minor minerals like zircon, accessory minerals like zircon, apatite, spin. These are the accessory minerals of granite. So these accessory minerals will be rich in uranium and thorium, apatite, spin, and zircon, etc. These are the accessory minerals. They may consist of uranium and thorium. But still, when you compare with feldspar and these minerals, feldspar is higher in content. So almost 4% of K2O consists of 40K. This is the concentration of 40K in granite. For almost 4% as K2O, we get 40K in granite. When it comes to thorium, thorium may be of 5 to 30 parts per million is the amount of thorium. 1 to 10 parts per million can be that of uranium, can be present in the granite. And when it comes to the radioactive type, 40K radioactive type is beta decay. Thorium and uranium is alpha, and beta decay is happening. So most of the decay will be of beta, then an alpha decay can happen in the granite. So 40K content will be higher, hence beta decay will be higher in the uh, granite. Okay, so this was not a very easy question, but if you know about the details, then the value will be okay. So let's see the last question that I remember from the GATE paper, that is the composition of three igneous rocks were given. Of three igneous rocks were given. They coined it as X, Y, and Z, and they gave the like minerals. Like X was having olivine, clinopyroxene, and orthopyroxene. Then Y had alkali feldspar, plagioclase, and quartz. Z is an igneous rock that consists of plagioclase, alkali feldspar, quartz, and biotite. So among these, which one is having the composition of felsic rock? So here we know that X is a ultramafic rock consisting of olivine, clinopyroxene. These are ultramafic one. And Y, which consists of alkali, feldspar, plagioclase, and quartz. So obviously Y is of the it is granitic in composition. Actually, granitic composition, or it is more felsic, more felsic than Z. Z is almost an or intermediate composition, whereas Y is more felsic in composition, more felsic. So the option answer should be the composition Y, which is more felsic. So these are the memory-based questions that we have. I remember, or my from the questions that I got from my students. So if you remember any more questions, you can comment it in the section in the comment section. So we'll be solving it out, and we'll make another video. Okay. So thank you so much for watching. Bye bye.